8th grade lesson 14.2 is trend lines and predictions. We're really just going to be piecing together pieces of information you already know, some of it from more recent, some of it from further back, and then we'll utilize that to our advantage for this lesson. We're going to first talk about trend lines, and I already was kind of using those in lesson 14.1, so this might be already familiar even though it hadn't been introduced yet. It makes good sense. So a trend line is just a straight line that comes closest to all of the points on a scatter plot. If you're seeing a pattern, you can kind of identify what the line or what a close line would be to those. Let's have a look at what that looks like. Okay, so we have the story of Joyce training for a 10K race. For some of her training runs, she records the distance she ran and how many minutes she ran that. So here's her distance in miles. And this is how long it took her to run those. Remember, that's bivariate data. There's two pieces of data to this. And to get my scatter plot, they ask us to go ahead and make a scatter plot. To get my scatter plot, there's my two pieces of data. We'll call that X and Y, two variables. And we're just going to graph it. 4 on the X turn, 38 on the Y. And then we will mark that. So 4 on the X turn and 38 on the Y is right below the 40 there. 2 on the X turn and go 25 on the Y right there. 1 on the X turn, go 7 on the Y, about right there. 2 on the X turn and go 16 on the Y, right there. 2 on the X turn, 3 on the X turn and go 26 on the Y. And 3 miles took her 26 minutes, right about there. 5 miles took her about 55 minutes up here. 2 and 22 miles took 20 minutes, right about there. 4 miles took her 45 minutes, 4 on the X turn and go 45 on the Y. And 3 miles took her 31 minutes, go 3 on the X turn and go 31 on the Y, right about there. So there's my scatter plot, and you can see a pretty clear trend. Our trend line is going to try as much as possible to go have the equal amount on the top as the bottom-ish. That really kind of goes through all of those data points. So we drew this trend line, we used a straight edge. I didn't have a ruler or anything, but as straight as I could get it. And draw a line that has about the same number of points above and below it. Ignore any outliers. If there was one way out here, I'd ignore that. They're all kind of grouped into this area, and so that fit nicely right in there. They say use your trend line to predict how long it would take Joyce to run 4.5 miles. Remember, this was trend lines and predictions, so you can use that trend line to make a prediction. So 4.5 miles would be right here. About how long should that take her? Probably around 45 minutes or so. Should take about, that's that weird equal sign, 45 minutes. So the trend line just kind of shows where most of the data lies, and we were kind of drawing those in the previous lesson anyway. The next part is finding the equation of a trend line. How would you find the equation of it? I know that sounds a little scarier. We just need to dust off a few cobwebs. This is a line. Our trend line is now a line. We have drawn the main trend, the main line. And if we dig back into our brains from earlier in the year, how to write an equation for the line, remember that is in y equals mx plus b format, where b is the y-intercept. It's where this line intercepts with the y-axis. Well, in this case, it's at 0. And m is my slope, m, remember the slope? That is rise over run. So we can find the slope of the line in one of two ways. We can just choose 2 points and go rise and run and get the reduced version of that, rise over the run as a fraction and get the reduced version of that. Or you can find 2 points and you can use the slope formula, dusting off cobwebs again, m equals y2 minus y1 over x2 minus x1 to find the slope. So we are going to do both in this example, so you can see both ways. But we're going to find out what the equation for this trend line is. I'm going to always, and I tend to always start with that y-intercept. I'm going to start with my y-intercept. That's at 0. So I really have a plus 0, which we tend to leave off, right? I don't need to say y equals mx plus 0. I can just say y equals mx in this case for this equation, because adding 0 doesn't change it. I need to find the slope m of this line. So I'm going to choose 2 points, and I'm always looking for 2 points that intersect beautifully somewhere along the way. And the smaller the numbers, the easier the calculations, right? So I noticed that 2 chapters, this is a scatter plot trend line that shows the relationship between the number of chapters and the total number of pages for several books. Okay, so 2 chapters tends to be about 20 pages. That looks like it's right on the graph there, so I'm going to put 220. And then I'm going to find another line that intersects nicely, maybe right here. That is 6 and 60. So one way to do this is to simply find, oh, I should have marked it on there, 6 and 60, is simply to find how much do I rise to get to that second dot, and how much do I run to get to that second dot, paying attention to how much these are increasing by. So from here to here, these are counting by 20, so I rise by 40. And I run by, these are counting by 2, so 2, 4. I run by 4. So I've written my slope as rise over run, and that's reducible fraction, right? 4 goes into both of those. 4 goes into 40 10 times and into 4 once, and that is 10. My slope is 10. So there's my equation. Now, if you don't want to use the rise over run, or if you're more comfortable using the slope formula, then let's go ahead and do that. Remember, this is, my first point chosen was 220, and my second point chosen was 660. So this would be my y2, this would be my y1, this would be my x2, this would be my x1. So I'm just going to plug those numbers into the formula. Y2 is 60, Y1 is 20, X2 is 6, X1 is 2, 60 minus 20 is 40, 6 minus 2 is 4, and have a look at that. I ended up with the same thing. And when I reduce that down, of course, I'm going to get the same answer. Y equals 10x. My slope is 10. It's going up 10 for every 1 over. So that's just that refresher, how to make, how to write the equation of the line. So that's the pieces we're putting together. We're saying, oh, a trend line is kind of what the pattern is showing, and then we're using that trend line to write an equation from what we learned at the beginning of the years. So B is y-intercept. If it does in fact intercept other than 0, then you'd put that number there. And M is the rise over run, or you could use the slope formula to find that. If you choose 2 points, you can find the slope. The last 2 vocabulary pieces they give us in this section is interpolate and extrapolate. Interpolate is a prediction that is between the data points that you already know. You've got it scatter plotted, you've got a trend line, you can see where the data is going and it makes sense. Extrapolate is a prediction outside of the data that you know and have in front of you, but maybe you are seeing enough information that can guide you to that. You can kind of extrapolate the get data, but if you have the data showing in front of you and a trend line and things like that, you can interpolate the data very well. That's it for this lesson. That's all they're showing us. I think you're going to do well on this. Good luck.